47 Chinese universities were already working on 6G research before many American cities finished arguing about whether 5G towers caused headaches. That sounds exaggerated. It isn't. In November 2020, China launched what it described as the world's first experimental 6G satellite into orbit. Not a full 6G network, not consumer infrastructure, a research platform. Early-stage terahertz communication experiments. Most people outside telecom circles barely noticed because the world was busy fighting over masks, lockdowns, and supply chains collapsing in real time. Meanwhile, inside China, the Ministry of Science and Technology had already made next-generation wireless systems part of a long-term industrial strategy. In the United States, by contrast, local governments were still holding town hall meetings about whether 5G towers were dangerous. Some protests were so intense that telecom crews in parts of Europe and North America had equipment vandalized. Britain literally set fire to towers during a pandemic. Human civilization is a remarkable species. And before somebody says, well, public debate is healthy, yes, of course it is. Democracies argue, that's normal. The problem is the clock doesn't pause while the argument happens. Because this isn't mainly about faster phone downloads. That's the surface-level version. The real story is about who controls the architecture of the next industrial economy. 6G isn't just another G. The projected bandwidth targets being discussed inside Chinese and South Korean research programs move into terahertz frequencies, theoretically allowing data transmission speeds measured in hundreds of gigabits per second, maybe even approaching 1 terabit under specific conditions. That's enough to fundamentally change what can exist economically. Autonomous logistics systems, real-time industrial AI coordination, remote robotics with near-zero latency, persistent augmented reality layers, military sensor fusion, entire factories communicating like nervous systems instead of separate machines. And the countries setting the standards for that infrastructure gets something much more valuable than prestige. It gets leverage. People forget this happened already with 5G. Around 2019, Washington suddenly realized Huawei equipment had spread across huge portions of the developing world's telecom infrastructure. Africa, Southeast Asia, Latin America, parts of Europe. The United States responded with sanctions, export restrictions, diplomatic pressure, and a campaign warning allies about national security risks. Some of those concerns were legitimate. I think pretending otherwise is unserious. Telecommunications infrastructure absolutely matters strategically. If a rival state builds the pipes, eventually they influence the flow. But here's the part that still feels strangely under-discussed. America reacted like this discovery was sudden. It wasn't sudden at all. Huawei spent years outcompeting rivals on price, deployment speed, and financing. Chinese state banks helped fund overseas projects through mechanisms Western firms often couldn't match. The Belt and Road Initiative wasn't just ports and railways. It quietly included digital infrastructure, fiber cables, cloud systems, smart city platforms, telecom networks. The phrase Digital Silk Road sounded abstract when Beijing introduced it in 2015. It looks less abstract now, and that's why the 6G story matters more than people think. Because the fight isn't happening at the moment consumers buy phones. It happens years earlier, when governments decide whether advanced infrastructure is treated as a strategic capability or just another partisan food fight. The Federal Communications Commission auctioned spectrum aggressively for 5G rollout, but American deployment still became fragmented. Different standards, different local permitting battles, different political narratives depending on which cable news channel someone watched that night. Meanwhile, China Mobile alone built hundreds of thousands of base stations, at a pace Western telecom executives openly admitted was difficult to replicate under market conditions. There's an uncomfortable tension here. The American system is extraordinarily innovative at the software layer. Nobody serious disputes that. The US still dominates cloud computing, advanced semiconductor design, hyperscale AI models, operating systems, venture capital depth. But physical infrastructure, industrial coordination, long-horizon state-backed deployment? That's where the comparison starts getting awkward. And the consequences reach ordinary people faster than most realize. If the next communication standard is shaped primarily around Chinese patents, Chinese equipment ecosystems, and Chinese manufacturing scale, then entire downstream industries start orbiting that gravity well. Devices become cheaper there first. Factories cluster there first. Developer ecosystems grow there first. Skills accumulate there first. Eventually, even foreign firms adapt themselves around standards they didn't create. We've seen this movie before with manufacturing. We're starting to see it again with industrial AI. The question is whether telecom becomes the next layer. And there's one detail from 2020 almost nobody paid attention to that tells you this may already be further along than Washington wants to admit. We'll come back to it. That overlooked detail from 2020 was not the satellite itself. It was who showed up afterward. Within months of China's early 6G push, research partnerships started forming between state laboratories, telecom giants, aerospace contractors, and universities, with a level of coordination that would look almost alien in Washington today. Tsinghua University, China Mobile, Huawei, CETC, the China Electronics Technology Group Corporation, which also works closely with defense systems. The point wasn't simply to invent a faster network. The point was to collapse the distance between research, manufacturing, deployment, and state planning into one pipeline. That matters more than the technology headline, because countries rarely lose industrial leadership in one dramatic moment. Usually, the decline looks boring while it's happening. A standards committee here, a delayed permit there, one generation of engineers retiring without replacements. A domestic supplier disappears because importing became cheaper. Nobody notices the pattern until dependency hardens into structure. The US actually lived through this once already with high-speed rail. America invented critical early rail technologies. Japan industrialized high-speed passenger rail. China scaled it into something almost incomprehensible. By 2024, China had built over 45,000 kilometers of high-speed rail lines, more than the rest of the world combined. Meanwhile, California was still debating timelines, land acquisition, legal challenges, environmental reviews, and exploding budgets. Different sector, same institutional reflex. And before this turns into simplistic, China-efficient, America-dysfunctional commentary, that's not quite right either. China's system creates its own distortions. Ghost infrastructure exists. Capital gets misallocated. Regional governments chase politically attractive projects because Beijing rewards scale. Some Chinese telecom investments will absolutely fail. But failure inside a scaling system looks different from failure inside a stalled system. One produces excess capacity. The other produces hesitation. Those are not equal problems. A lot of Americans still think technological leadership works the way it did in the 1990s. Invent something important, let private markets optimize it, then enjoy dominance naturally. That model worked during a period when the United States had overwhelming advantages simultaneously in capital, talent attraction, semiconductor manufacturing influence, software ecosystems, naval security, and global finance. Today's environment is tighter. China graduates more STEM students annually than the United States, by a margin large enough to alter industrial math. According to OECD and Chinese education figures, the difference in engineering-related graduates isn't marginal anymore. It's systemic. Quantity alone doesn't guarantee innovation, obviously. But when you combine engineering scale with aggressive state financing and huge domestic deployment markets, iteration speeds increase. That's the key word here. Iteration. People obsess over invention and ignore iteration. Yet historically, the countries that dominate industries are often the ones that improve technologies relentlessly after the breakthrough moment. Britain pioneered early industrialization. America mastered mass production. Japan perfected manufacturing quality control. South Korea turned consumer electronics into precision export machinery. China studied all of them, very carefully. There's a reason Beijing's Made in China 2025 strategy caused so much anxiety in Washington years ago. Western coverage often framed it as propaganda branding, but buried inside were explicit targets for robotics, aerospace, semiconductors, EVs, telecom equipment, biotech, and AI-linked infrastructure. It read less like a slogan and more like a procurement blueprint for the next 20 years. And telecom sits underneath almost all of it. A self-driving truck network does not work reliably with unstable, low-latency coverage. Distributed industrial robotics don't tolerate communication interruptions well either. Neither do military drone swarms, automated ports, or real-time AI manufacturing systems. Once you start viewing communications infrastructure as the nervous system of an industrial state, China's obsession with network leadership suddenly looks less mysterious. Honestly, the American debate around 5G sometimes felt trapped inside consumer thinking. Faster streaming, better phone reception, download speeds. Useful, sure, but Chinese planners were looking at ports, mines, energy grids, logistics corridors, autonomous factories. Different frame entirely. One small example stayed with me. In 2021, the Chinese mining company China Energy reportedly began deploying AI-assisted autonomous haul trucks in Inner Mongolia, connected through high-speed private 5G industrial networks. Massive mining vehicles, each weighing hundreds of tons, coordinating routes with minimal human input in brutal winter conditions. Not a prototype demonstration for investors. Operational infrastructure. That is not really a telecom story anymore. It's an industrial operating system. Meanwhile, American telecom discussions kept collapsing into either culture war arguments or quarterly earnings pressures. Verizon and AT&T had investors demanding returns now, not 10 years from now. Chinese state-backed entities could tolerate longer timelines because the strategic payoff mattered more than immediate profitability. Different incentives create different futures. Although, and this is where the story gets more complicated, China's apparent lead may also contain a hidden weakness, a serious one, because building the network is not the same as controlling the most valuable layer sitting on top of it. And that's where the next phase of this gets interesting. For all the anxiety about China building the pipes, the United States still owns an enormous part of the intelligence flowing through them. That's the reversal people miss. The same America that struggled to coordinate basic 5G deployment also created the companies powering the modern AI stack almost by accident. NVIDIA, Microsoft, Google, Amazon, OpenAI, AMD, Anthropic. The most advanced, large-scale AI infrastructure on Earth still runs disproportionately on American-designed chips, American cloud architecture, and American software ecosystems. Which creates a strange possibility. China could build more advanced communications infrastructure while the United States controls a huge portion of the cognitive layer riding on top of it. Imagine owning the highways but not the trucks. Or owning the electrical grid while somebody else designs every appliance plugged into it. That tension sits underneath almost every major technology confrontation happening right now. Washington understands this now, which explains why the policy tone changed so sharply after 2022. The Biden administration's semiconductor export controls were not ordinary trade policy. They were an attempt to slow China's climb specifically at the compute layer. Advanced GPUs, AI accelerators, semiconductor manufacturing tools, extreme ultraviolet lithography access. The October 2022 restrictions, later tightened again, effectively told the world, certain technologies are no longer treated as normal commercial goods. They're strategic assets. The logic was straightforward enough. If China combines advanced telecom infrastructure with frontier AI capability, the balance shifts dramatically. Not just economically, militarily too. High-speed communications plus AI plus autonomous systems become something larger than the sum of its parts. And to be fair, the restrictions hurt. Huawei's smartphone business collapsed after sanctions severed access to advanced chips and Google services. SMIC, China's leading semiconductor foundry, still faces major manufacturing bottlenecks because ASML in the Netherlands cannot legally export its most advanced EUV lithography systems to China under current restrictions. Cutting-edge chipmaking without EUV is like trying to mass-produce surgical instruments wearing winter gloves. Technically possible, painfully inefficient. But then something happened that genuinely surprised a lot of analysts. China adapted faster than expected. Not perfectly, not completely, but faster. In 2023, Huawei released the Mate 60 Pro, containing what analysts believe was a domestically produced 7nm class processor manufactured by SMIC. The phone wasn't globally dominant. That's not the point. The point was symbolic and strategic. Sanctions designed to freeze progress had instead accelerated parts of China's domestic semiconductor ecosystem. Pressure can do that, especially when a country concludes dependency itself is now the existential risk. I don't think enough people in Washington fully absorbed the psychological shift that occurred after those sanctions. Chinese policymakers stopped viewing technological self-sufficiency as an economic ambition and started treating it like national survival. Once a state reaches that mindset, timelines compress, funding expands, bureaucratic resistance weakens, and ironically, American restrictions may have helped unify Chinese industrial policy internally. There's precedent for this historically. Japan's post-war industrial rise accelerated partly because external vulnerability forced coordination between banks, manufacturers, and the state. South Korea did something similar during its heavy industrialization phase. External pressure often creates domestic discipline. Of course, there's a counter-argument here, and it's not weak. Some economists believe China's model eventually hits diminishing returns because genuine breakthrough innovation requires openness, intellectual freedom, and decentralized experimentation. There's evidence supporting that view. Silicon Valley culture emerged partly because researchers, startups, universities, immigrants, and investors interacted chaotically rather than through central planning. Many transformative inventions arrive from directions governments fail to predict. That's true. But here's where I think the debate becomes too binary. People talk as if the future must belong entirely either to centralized state coordination or decentralized market innovation. Reality may end up uglier and more hybrid than either side expects. China is learning venture-style experimentation faster than outsiders assume. America, meanwhile, is becoming more willing to use industrial policy after decades pretending it didn't. Look at the Chips and Science Act. That's industrial policy. Washington just avoids calling it that because Americans associate the phrase with other countries. The deeper issue is whether democracies can still execute large-scale infrastructure transitions before internal fragmentation slows them down. And this isn't abstract anymore. Ordinary consumers already feel pieces of it. Electric vehicles increasingly depend on Chinese battery supply chains. Solar panels too. Critical minerals processing, industrial drones, telecom hardware, even parts of pharmaceutical manufacturing. Every dependency looks manageable individually. Together they form a map, one that keeps expanding. Remember that point from earlier about standards? Here's where it lands. If Chinese firms help define technical standards for next-generation networks across emerging markets, software developers and hardware manufacturers gradually optimize around those ecosystems. Over time, switching away becomes expensive, then politically difficult, eventually almost impossible without major disruption. That's how infrastructure power works, slowly at first, then all at once. The United States understands this perfectly when the infrastructure is financial. Dollar dominance, swift access, sanctions leverage, reserve currency status. Washington knows standards create gravity. China learned the lesson, and it's applying it elsewhere, which raises an uncomfortable question heading into the next decade. What happens if the country building the world's industrial nervous system isn't the same country writing the software intelligence running across it? Because history suggests technological bifurcation rarely stays peaceful forever. I keep coming back to something a former Google CEO, Eric Schmidt, said a few years ago during discussions about AI and strategic competition. He argued that whoever reaches dominance in key emerging technologies first may create advantages that compound faster than political systems can react to them. At the time, that sounded slightly dramatic. It doesn't anymore, because the real story underneath the 6G race isn't telecom. It isn't even China versus America in the simple Cold War sense people keep forcing onto everything. The deeper issue is whether modern democracies can still concentrate attention long enough to build foundational systems before the argument consumes the project itself. And I say that carefully because public skepticism isn't automatically irrational. Governments lie sometimes. Corporations absolutely chase profit at public expense. Citizens should question infrastructure decisions that affect health, privacy, security, and local communities. But there's a difference between scrutiny and paralysis. China understands that infrastructure compounds. Build enough ports and trade routes shift. Build enough factories and supply chains migrate. Build enough telecom networks and eventually entire digital ecosystems begin orbiting your standards almost by inertia. The strategy isn't mysterious, it's cumulative. The United States, meanwhile, often behaves like a country that still assumes dominance is the default outcome if it simply invents the first version of something. That assumption is aging badly, especially because invention has become only one phase of competition. Scaling matters, manufacturing matters, deployment speed matters, energy availability matters, technical education matters, regulatory coherence matters. Even boring things like transformer production and permitting timelines suddenly matter again. History has a cruel sense of humor that way. After decades celebrating a post-industrial economy, advanced nations discovered physical infrastructure was still real. Steel pipes remain stubbornly difficult to replace with TED Talks. And yet, I don't think China's position is as invincible as either its supporters or critics sometimes claim. There are fractures underneath the surface. Demographics are worsening. Youth unemployment became politically sensitive enough that Chinese authorities temporarily stopped publishing some statistics in 2023. Local government debt is heavy. The property sector still looks unstable despite intervention efforts. Semiconductor dependence at the absolute cutting edge remains unresolved. And the more technologically capable China becomes, the harder Western containment efforts will push back. That friction is not going away. If anything, we're entering the decade where the collision becomes visible to ordinary people instead of policy specialists. Consumers will notice through prices, software ecosystems, AI platforms, app restrictions, supply chain disruptions, and competing technology standards. Businesses will notice through procurement rules and export controls. Militaries already notice. The clean globalization era is ending in slow motion. What replaces it probably won't be a complete technological iron curtain either. That's too simplistic. The global economy is too intertwined for clean separation. Apple still depends heavily on Chinese manufacturing. China still depends on foreign semiconductor equipment. American firms still want Chinese markets. Everyone is entangled with everyone else, which makes the situation more stable in the short term and potentially more dangerous in the long term. Because interdependence can discourage conflict right up until the moment it stops doing that. My own view? I think the next 5 to 10 years will produce a split technological world, but not a symmetrical one. The United States will likely retain leadership in frontier AI models, advanced chip architecture, and high-end software ecosystems longer than Beijing hopes. But China may dominate the industrial deployment layer, smart logistics, manufacturing automation, telecom infrastructure, electric transport systems, machine-connected urban infrastructure at massive scale. One side builds the brain, the other side builds the body. And if that division hardens, every smaller country gets dragged into difficult choices about which ecosystem to integrate with. Not because ideology suddenly matters more, but because standards create dependency. Once your ports, hospitals, factories, telecom systems, and financial rails are optimized around one technological sphere, switching costs become brutal. This is why the 6G conversation matters long before consumers ever see a 6G icon on their phones. By the time the branding arrives, the important decisions are usually already over. Honestly, that's probably the strangest part of modern technological competition. The public experiences these shifts at the very end. New phones, new apps, slightly faster streaming, while the real battle happened years earlier inside standards bodies, export control meetings, research labs, rare earth contracts, and industrial policy documents nobody outside government reads voluntarily. Well, almost nobody. And remember those tower protests from the beginning? The arguments about whether 5G itself was dangerous, while China accelerated long-horizon telecom planning? That contrast wasn't just a funny internet moment. It may end up being remembered as an early signal that the two countries had developed completely different relationships with infrastructure, expertise, and time itself. One system argues in public until consensus forms. The other moves first and deals with consequences afterward. We'll find out which model adapts better to the century that's arriving, preferably before the 7G meetings start.